Okay, Algebra 2 fans, our topic for today is an introduction into probability. And this is going to be a mix of a couple topics here. We're going to get into odds. We're going to talk about some games, some gaming theory. So it's probability, but there's going to be a little bit more mixed into it as well. So before we start, here's your joke of the day. Why do cannibals not like to eat clowns? And the answer is because they taste funny. All right, so we're going to start with the idea of odds versus probability. So when you're looking at an event, okay, we're going to assume the event has two outcomes, what we call success or failure. Now it could be winning and losing, but we're going to think of it in terms of success and failure. Okay, no ties. We're not going to look at ties. When you look at odds, odds is the ratio of the number of successes to the number of failures. So in sports, you may see the odds of a game, of a match. The odds that one team beats another are 3-2. And the way that we actually read that is 3-2-2 when you have that colon. What is the probability of winning? Well, the probability of winning is not the fraction 3/2. It's actually going to be, and I'm going to say PW. So that's the probability of winning. There are 3 ways to win. This is saying there are 3 successes for every 2 failures. So it's actually going to be 3 out of 5 is the probability winning. Because the overall number of ways that this can happen, there are 5 ways. 3 plus 2. 3 successes, 2 failures is 5 outcomes. So the probability that you win is 3/5. Now, as a decimal, that's 0.6. Well, the probability of losing then is there are 2 failures out of 5 outcomes, and that's 0.4. Now, one of the most important concepts here is that when you add probabilities together as decimals, they always have to add up to 1. Probabilities add up to 1 because 1 is the same thing as 100%. So when you say 0.6, you're saying there's a 60% chance that you win, there's a 40% chance that you lose. Now another way to come up with this value, the probability of a loss, is to take 100% and subtract 60%, or we're going to take 1 minus 3/5. So another way to get that is just take out the probability that you win, and everything else is going to be the probability that you lose. All right, so let's say that the odds are 5-3. The probability of winning, it's not 5/3, it's 5/5 successes for every 3 failures is a total of 8 outcomes. So that's 5 out of 8, which is 0.625, 62.5%. The probability of losing, if you wanted to figure that out, would be 1 minus 5/8, and that would be 0.375, or 37.5%. So the idea of probability, the probability of an event occurring, is the number of outcomes for that event to happen divided by the total number of outcomes possible. So if we're talking about success, the probability of success is the number of ways to succeed divided by the total number of possible ways of doing something. So that would be the successes plus the failures. Now, a classic example of this is marbles. Okay, so let's say here's the situation. We have 10 marbles in a jar, 4 red, 3 blue, 2 green, 1 yellow. And if you add that up, you have 10 marbles. If you choose 1 marble, what's the probability that you choose 1 red? Well, in this case, our success would be taking a red, would be choosing a red. There are 4 reds in the jar out of the total number of possible marbles to choose is 10. So you have 4/10. Now we can reduce that to 2/5. A lot of times you'll think of probability as a decimal. Okay, so 2/5 or 0.4, that's up to you. What's the probability that you choose a blue? Well, there are 3 blues total out of 10 total marbles. So 3 out of 10, which is 0.3, 30%. Go ahead and feel free to work ahead on these and then come back to the video and see if See if you agree with what I get. The probability of a green, well, 2 greens out of 10, that's 1/5. If you reduce, that's the same thing as 0.2. The probability of a yellow is probability of y, 1 out of 10, which is 10%, 0.1. And if you add 0.4 plus 0.3 plus 0.2 plus 0.1, you should get 100%. And I can check that, 0.4 plus 0.3 plus 0.2 plus 0.1, and we get, there's 1. Okay, 100%. So what that means is that if everything adds up to 100%, you have taken account of all the possible outcomes. If I pick one marble, this is the only thing that can happen. I get a red, a blue, a green, or a yellow. On the side here, I could put one more problem here. What's the probability that I get a white marble? Well, that would actually be 0 out of 10. Why? There are no white marbles. Okay, now typically I'm not going to put a problem like that on there, but technically the probability of white is 0. The probability of black is 0. The probability of purple is 0. Okay, so number 4. The game changes a little bit. What if you now choose 2 marbles in sequence without replacement? Now what that means is that we're going to take a marble, but we're not going to put it back before we take the second one. What is the probability that we choose a blue and then a green in that order? Okay, so it's going to be in that order, the probability of blue and green. So we'll start with the probability of a blue marble. Now we're using the same information from the first problem here for problem 3. So the probability of a blue is 4 out of 10. Now here's the thing. So let's say we pick a blue. In the second marble, so we pick a blue but we don't put it back. We don't have 10 marbles anymore now, we have 9. Now if we're going to pick a green, there are a total of, blue was 3 out of 10. 3 out of 10, not 4 out of 10. So 3 out of 10. And then for a green, well, we had 2 greens. Now there are only 9 marbles left though in the bucket or the jar because we've already picked one. So it's 2 out of 9. Now if you think back to counting principle, the number of ways of doing something, what you do is you multiply your values at the end. Okay, so I take the probability of blue, I multiply that by the probability of then picking a green. Now you can do some reducing first. You can multiply, a couple ways to do this. You can multiply the tops of the fractions, the numerators, you get 6 over 90, which you can then reduce, and what you get is 1 out of 15, which is approximately 0.067, so about 6.7%. But the other thing you can do, which might be easier, is to actually reduce first. I can take any number in the numerator and divide it by any number in the denominator. I can reduce 3 and 9. That'll give me 1/3. I can do 2 over 10, which reduces to 1/5. And notice that what's left over, if I multiply in the numerator, 1 times 1 is 1, and 5 times 3 is 15. And there you go. That might be a simpler way to do it. All right, what's the probability that we pick a yellow and then a red? Well, there's only one yellow to start with, so the probability of a yellow is 1 out of 10. Okay, 10 marbles to choose from. We're trying to pick the yellow. So let's say we pick yellow. Now we want to pick red. We have 4 red in the jar, but how many marbles are left? It's not 10 anymore, now it's 9. And now we multiply, although what I would do again is I would reduce first. 4 over 10 is 2/5. And what we have is 2 in the top over 45. As a decimal, it's 0.044, 0.044. Or you could put a 0 in front, 0.044. It's about 4%. So not great probabilities of doing this. All right, what's the probability that we pick 2 greens? Well, we have 2 greens to start with, so the probability of picking the first one is green, 2 out of 10. All right, now, to take the second green, we don't have 2 greens anymore. We only have 1 left. So there's 1 green left out of there are 9 marbles left because we already took one. So it's not 10, it's now 9. And if we kept going, it would be something over 8, and then 7, and then 6. We can reduce 2/10, that's 1 over 5, and what we get here is 1 over 45. So that would be approximately 0.022, so about 2%. Not, again, great probabilities, not great odds for you. Now the last one is red, yellow, in that order. We have 4 red, so that's 4 out of 10, times we have 1 yellow, that's 1 out of 9, because there's one less marble because we already picked one. And again, we'll reduce 2 over 5. 2 times 1 is 2. 5 times 9 is 45. Whoops. And we've already seen that's 0.044. Now one thing that you might notice here is that the probability of a red and yellow is the same as the probability of a yellow and red. Okay, so it doesn't really matter. They should be the same. It doesn't matter what the order is. You're going to end up with a yellow. You're going to end up with a red. So yellow, red is this. Red, yellow is this. In this order. If we said that the order mattered, that these two were different, then we would add these up, and it would be about an 8% chance that you would get a red and a yellow in some order for that. All right, so let's flip it over here, and let's start talking about cards. Now, in a deck of cards, you got to know a couple things in a standard deck. First of all, there are 52 cards in a deck. Half of them are red. So half of 52, if you take 52 and divide by 2, you get 26. Half of them are black, so that's also 26. Face cards, well, that's going to be your jacks, queens, kings, and we're also going to include tens on that, okay? And the reason why is we'll get to that in a little bit. So for face cards, well, actually, let's not put the tens in yet. Let's not worry about tens. Jack, queens, king. Every type of card numerically, ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, there are 4 of each type of card. So for face cards, you have 12. 4 jacks, 4 queens, 4 kings. Spades, clubs, hearts, and diamonds, those are called the suits. They're also going to be the same number of each suit. And since you have 52 total, and there are 4 different suits, if you take 52 and divide by 4, what you get is 13. So there are 13 spades, 13 clubs, 13 hearts, and 13 diamonds. 13, by the way, is if I count ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, there are 13 types of numbers or letters. So you have each card. So you're going to have an ace of spades, an ace of clubs, an ace of hearts, an ace of diamonds. And so what that means is that there's going to be 13 of each. Okay, so let's see if we can do number 5 here. If you choose one card at random, what is the probability of a heart? Well, 13 hearts, that's the number of ways to be successful, out of a total of 52 cards, and that actually reduces to 1/4 or 0.25, 25%. What's the probability of a red card? Well, we have 26 red cards out of 52. So the probability of a success divided by the total number of outcomes. The number of ways to succeed divided by the total number of outcomes. That's 1/2, which is 0.5. Or 50%. The probability that you pull an ace, well, there are 4 aces out of 52. So that reduces to 1/13. As a decimal, that is 0.077. The probability of a face card, well, there are 12 face cards out of 52. That would reduce to 3 out of 13, which is 0.231. Now that is the end of part 1 of the notes, so go ahead and go to part 2 and we'll continue.